Hello and welcome to this talk at the 3D Expert Summit. My name is Florian Bauer. I'm Chief Solutions Officer at the Semantic Web Company, and I would like to talk to you today about the concept of the Semantic Content Hub. I will talk about how we think that it's possible to transform unstructured data into comprehensive knowledge discovery solutions. And I'm very much looking forward to have a conversation with you at the end of that session in our question and answering. So let me get started with talking about the challenge. According to projections from IDC, 80% of worldwide data will be unstructured by 2025. And that's a massive challenge that we all know about and we want to solve. Why is it a challenge? Because text and language very often is imprecise or ambiguous, especially for machines. Computers do not understand the language because they don't have the necessary background knowledge, and that's why we need to bring that knowledge to computers to be able to process it. Texts are often written multilingual, that's great, but similar a challenge for automatic processing and understanding the content. And as we know, unstructured data is very, very diverse, and to be able to process it further, we need to put it into a consistent form. We need to have a kind of a basis to allow further automated processing. And last but not least, it's quite a challenge to be determined for conventional searches. It's quite a challenge to determine what is the actual information need that a user or a customer or whatever has, because the underlying data is in unstructured form. So as you can see, lots of challenges, but there are solutions to that, and I would like to walk you through that today. So what we want to do is we want to build a content hub that has a semantic understanding. So we want to build that semantic content hub that is able to overcome these challenges that I mentioned. And to do so, there are several steps we can take. So let me take you through these steps from a crawl phase to, at the end, you will see there is a phase where we consider it to be the fly phase. So as a first step, what we need to do is we need to learn how to manage taxonomies and ontologies, how to bring that kind of knowledge in a structured way, in a machine-readable format, and how we manage it centrally. I'll come to that point at a later stage, why this is so important. So after we have done this, after we learned how to crawl, we want to walk. In that second stage, there are already quite exciting possibilities, like automatic tagging, automatic classification, named entity recognition possibilities, semantic footprinting, and so on. I'll not talk about all of those, but some today. And then once we have learned to walk, there is a possibility to do even more with that. And there it becomes really interesting when we apply semantic search capabilities to our content platforms, when we add recommendation systems, question answering capabilities, and so on. And if you combine all of these things, if you have achieved that there is a combination of all of this, we consider that the fly phase, where you have a semantic content hub that really fulfills all the needs of your users and customers. So first step, I would like to go now step by step through some of these phases to give you a better idea on how this can be done and what is behind this. First step, centrally managed taxonomies. Let me start with a very quick explanation what a taxonomy actually is. A taxonomy is kind of a knowledge organization system. So it is, very simplified, a set of words that have somehow been organized, and it's a possibility to ensure that we use those words in a controlled way. Usually, these kind of taxonomies are specific to a knowledge domain or a subject area, and that's why it's important to always bring in subject matter experts to build those kind of taxonomies. So very, very briefly, taxonomies usually include labels, so the terms describing them, their hierarchical relationship, other labels that also describe them, like synonyms, abbreviations, and so on, and also often definitions. So the key principle here, it's all about things and not strings. So it's all about something and not the way how it is described, not the main label that is attached to it. And that's very important for everything that will come next, and I'll show you why. So what we want to do when we talk about the Semantic Content Hub, we want to use semantic concepts instead of simple terms to annotate our data and content. And that comes back to the previous slide where I said it's things and not strings. So we want to use concepts rather than just the words that describe them. And so that we all have the same understanding what I mean by when I talk about a concept, I've put a very simple example here. It's like, what do you see here, right? Some of you might say, that's a bell pepper, that's a pepper, that's a red pepper, that's a capsicum. Who knows? But it's all the same thing. So this is all the same concept. Yeah? And we need to ensure that the machine is able to understand that and is able to process this in that way. So when we talk about concepts, we mean the description of something in its full extent. Why do we need that? Because what we want to achieve at the end of the Semantic Content Hub is that we actually have something that ensures that we refer to those things and not strings, so these concepts, because that introduces already some explicit semantics that we can use for any kind of applications, for search features, for tagging capabilities, for reusing, and so on. It's very important that this kind of first structure already introduces the basics for being able to do that. And all of that is based on something that's machinable and is something that is controlled centrally. And that's the third point. I do think that it's very important to manage that point, because you have a chance here. If you are modeling that, if you're creating that domain model centrally and manage it centrally, you will have a single source of truth of that knowledge model across all your different systems. And because these things can be done in standardized ways based on well-known standards, it can also be used by all sorts of different systems then at the end. So getting back to my initial slide, we now have touched very briefly the topic of taxonomies. I'll not go into ontologies today. There are other webinars where we do this, but I'll leave it with the taxonomies for the crawl phase. Great, we can crawl. Now let's see how we can learn to walk. And what I'll pick out today is the automatic tagging and classification part. So what we want to have in a Semantic Content Hub is we want to have automatic tagging, but we want to have it in a smart way. The key here is, again, these concepts that I mentioned before. So here you see a recipe. It says, finely dice the onion, bell pepper, and coriander, mix well in a bowl and add lime, olive oil, and salt. What we can do when we model this kind of domain in taxonomy, we can add all that knowledge to that concepts that are mentioned here. So the capsicum is actually a bell pepper, also referred to a paprika. There is a subtype of a red capsicum here that is modeled in that simplified model with red bell pepper, red paprika as synonyms. For the onions, the same. Red onion, sweet onion is a synonym here. And the shallots is a kind of a child concept of an onion. This allows us now to do that kind of automatic smart tagging, because what you will see here is that we can automatically apply these kind of concepts as tags to that text. So the onions is applied to the onion, the lime is applied to the lime, but here you already see the concept of the capsicum is applied to the bell pepper. And this will become very important when we talk about further use cases like semantic search in a later stage. So we now have successfully automatically tagged that content based on concepts and not just based on terms and strings. At that point, I would like to add one quick additional thing, which is quite important. When we talk about the Semantic Content Hub, I think it's important to consider that we want to bring in also experts in the tagging process. It's not always the best solution to do it fully automated. So we call it the expert assisted tagging, and that works in a way that if you have your content management system, your content creators select the text that they want to annotate, that they want to tag. It will be sent to a system to do that automatically, like in our case, the Pool Party Semantic Suite, with its taxonomy management and entity extraction capabilities. So you will receive a document that is annotated with these tags that came from the system based on the knowledge graph. That will already be very precise. but sometimes you want to have experts to have a look on that to even further improve the quality. And that's possible in this kind of way, how it's implemented in a lot of systems, where you have a review step then there, which allows experts to have input in that phase and then save it back to the content management system. And great news, AWS has included exactly that in next version of Tridion. They call it the smart tagging for Tridion, which now allows you, based on the pool-party semantic suite, manage taxonomies in multiple languages and use them for tagging in multiple languages. Also, the system allows you to build your taxonomies with kind of machine-assisted knowledge modeling. I'll not go into detail of that topic today. If you want to search for more information on that, I recommend to use the terms corpus analysis on the pool-party website, and you will learn more how this works. But the important thing here is you will have with Tridion and the smart tagging the possibility to automatically tag content, and as mentioned previously, there is a possibility to bring in the experts at that phase to review and to have a human-in-the-loop approach towards that automation. So this is basically combining best of both worlds. On the one hand side, the automation, which can process a large amount of content very quickly, but also bring the quality assurance by experts into play. So great, we now can walk, but we want to run. And from that third phase, I'll pick for today the semantic search as a first topic and go into the recommender systems at the end of the presentation. But first, let's have a look at semantic search. What we want to achieve there is we want to have search that actually is able to match user intent to content. And that's not as simple as it sounds, as we all know. I'll go back to my example of that recipe now. So let's consider a conventional text-based search approach here. We have the text, which is finely dice the onion, bell pepper, and coriander, mix well in a bowl, and add lime, olive oil, and salt, as we know. If someone now asks a question like this, like, what can I make with shallots, green lemon, sea salt, red capsicum, and cilantro? You will very likely not get an answer, because none of these terms actually appear in that recipe. And that is a big challenge for conventional text-based search. And there comes into play what we now prepared with all the steps beforehand, with creating the taxonomy, with having a concept-based approach, and so on, that we will be able to solve this. So in the Semantic Content Hub, we will be able to solve this by applying that concept-based tagging to that recipe, as we have done before, and making the links between the things in the question to what is written in the recipe by using that concept. So now we find an answer, because the system suddenly will be able to make the link between the shallot and the onion, the green lemon and the lime, the red capsicum and the bell pepper, and the cilantro and the coriander. Just to bring back to you what we have seen before, we need the kind of concepts from the knowledge graph to be able to do that. And here is again the slide from before, so that you can see how these matches actually worked out. And I'll just take one here. Let's take the green lemon. The green lemon is an alternative label of lime, so there is a direct connection here. And again, this is something that AWS has now included in Tridion, called semantic search. Now it's possible to apply that concept of semantic search, to use it in Tridion by using concepts instead of terms in the search. So this is the concept-based search again. There are other features now, like it's possible to perform searches based on partial inputs. So this is kind of the autocomplete mechanism. Also here, it's smarter than just autocomplete a sentence that someone else already wrote, because it's taking into consideration the synonyms of everything you type. And of course, there are possibilities like faceted search with dynamic filtering capabilities now also in Tridion. All of that is based on that concept of the Semantic Content Hub, And Pool Party Semantic Suite is the underlying tool to provide that services and possibilities. So now we are in the run phase, and we have achieved that crawl, walk, run already with one of each of those points. So we talked about taxonomies, automatic classification, semantic search, and of course that's already quite close to a real semantic content hub. But as I said in the beginning, there are a lot of other possibilities here. There is possibilities of named entity recognition, question answering systems, recommender systems, and so on. And for today, I just want to pick out one, which we think is quite an important one for the future, that really should be considered in Semantic Content Hub environments, which are the recommender systems. So when we talk about recommender systems, I just want to give you a quick input on why we think that this is so important, because we all want to get the right information to the right people, right? And we all know that there's a lot of information there and a lot of content that people can benefit from, but very often it's not possible to find it. They don't know how to best look for it. They don't even know that the information is there or know where and how to find it. So what we want to ensure with recommender systems is that we make matches of what things go together. This is far beyond the standard search because of the things that I mentioned before. We want to ensure that the recommendations are really done based on an understanding of what people need to know at what time. And when we talk about recommender systems, probably the first thought is, that's the thing that I have seen in my big e-commerce platform where I bought one thing and I get recommended what others have bought before. This is not really what I'm getting at. What we are really talking about here is to create recommendation systems in expert solutions that are not just e-commerce environments and suggest more of the same. We really want to do recommendation systems here that provide recommendations based on what the user needs and based on an understanding of the underlying data and information. So the hypothesis here is that with implementing a recommender system, this always allows you to turn raw data into personalized offers, and we all know that personalized offers result in a much higher customer satisfaction, better decision-making, and knowledge discovery. I want to get back to this, but it's not that same of the more of the same thing, because I think it's quite important to cover this here. We all know this collaborative filtering stuff from e-commerce, where, you know, I bought a board game, I get another board game recommended. I bought some Lego, I get another Lego recommended. This is not really what we want to achieve here, but we really want to achieve a good understanding of what the user needs and what the content can provide for this user need. And just one example to illustrate this is when you think about furniture shop. If I bought a green couch, I do not need another green couch or sofa, right? What I need is I need recommendations of things that fit into the situation I'm in, because I maybe want to have furniture for my living room. And maybe there is another constraint to that I have a cat at home, and so I would not want to have material recommended that goes bust after the second time the cat ran over it. So this is kind of this personalized offers I'm talking about that we can achieve with recommender systems based on knowledge graphs and semantic AI. I'll give you a quick example. This now is an example from the human resources sector. We have built a demonstration system that shows you on how we can do these recommendations based on semantic matches. So the use case is here, you are an organization that wants to make best use of the data that they have, both for the HR staff to find new candidates for open positions, staff projects, and so on, but also for employees to do some kind of self-service here. And what employees should be able to do here is to connect with other interesting co-workers, to browse some projects, to find career opportunities, and so on. And I'll run you through that demo in a second. So let me guide you through this demonstration. What you see here is a demo interface of an artificial company with artificial people created by a CV generator, so no worries about data protection issues here. But what you can see is the possibility for an employee to log into the system to get recommendations of talking to other people, finding new jobs in the company, and so on. I'll choose Keith today, who is a software developer in the organization. So you can see already that Keith gets some recommendations about other interesting people to talk to, about projects, about jobs. But how was this done? Actually, it was done by using the semantic footprinting. So if I go to Keith's profile, you'll see that he uploaded a CV to the system. And what we did is we used Poolparty's capabilities to extract the most relevant concepts from that CV, which form at the end the semantic footprint of Keith as a person in the system. And we are using that footprint to make recommendations. So if I go back now, we can see that we get recommendations for either employees, projects, or positions. I'll choose projects for now. So here you get all projects that are uploaded to the system, which again is uploaded in unstructured format. So if I click on one of these projects, you'll see there is a text description of the project. We did the same as with the profile of Keith. Poolparty was extracting the concepts from that text to create a semantic footprint of the project. And now we are able to match this. We are able to match Keith as a person with a project and the project description. You get them ranked already by relevance, but it's not just the matches about one-to-one thing. So it's not just about the match of a word that appears in the project description and the same word appearing on the CV of Keith. No, it's far from that. It's actually using the knowledge that is in the knowledge graph to make much smarter recommendations than just doing that one-to-one matches. And one example you see here in light gray are those concepts that are inferred by using the knowledge from the knowledge graph. So Keith did not mention in his CV that he is a front-end developer. The project, though, was asking for a front-end developer to work on. However, because we have that knowledge in the knowledge graph, that several skills that Keith put into his CV actually are skills relevant for front-end developers, we can make that recommendation, even though it's not explicitly mentioned in his CV that he is capable of doing front-end development jobs. So by that, you get much more precise and personalized recommendations than before. And of course, we can add further personalization to this. So here, for example, Keith could say he's not so interested in natural language processing projects. You saw in the bottom that the ranking changed. And that's because we changed the weighting of the different concepts related to natural language processing and therefore can make personalized recommendations. So let me go back to my presentation because that already shows the power of recommendation systems in that kind of personalized way, using taxonomies, using semantic footprinting, and so on. What we have done to achieve that demonstration system, we have used Poolparty and various components of Poolparty. So we have used the graph management of Poolparty with the taxonomy and ontology modeling. We have used the extraction modules of Poolparty with automatically extracting concepts from those texts, from the CVs, from the job descriptions. We've used the corpus analysis that I still recommend you to have a look on if you're interested to further improve the knowledge graph and the results. And of course, we have used the graph automation, which was the possibility to get the data from various different systems. So as a summary, I do think that semantic content hubs are really the best way towards a lot of different things. Most important one, finding relevant documents and content faster. Do that more accurate by filtering of, on the one hand side, relevant, but also of non-relevant information because you don't want to show that. All of that should be done based on consistent tagging, based on controlled vocabularies, which adds another component to that whole picture with another benefits in a wider sense that can be reused in other projects and so on. What we do there is we achieve high standards based on metadata of high quality, and metadata is really important to have that in a high quality, quality ensured way. And last but not least, it is the possibility to connect structured and unstructured information across various different systems, because that's the challenge that most organizations actually face. So to summarize, semantic content hubs can already be built easily with using features of the Pool Party Semantic Suite. And the great thing is that we have now seen with the integration in Treaty and Docs and Cite that this is already available, called smart tagging and semantic search, also on the AWS products, Treaty and Docs and Cites. So with this, I will end the presentation for today. Thank you very much for the invitation. I'm very happy and keen to go into the Q&A session, answer your questions. If you want to reach out to me, please do so. I would be very happy to respond to your emails or connect via LinkedIn. And with that, thank you very much and see you in the Q&A session.